Hi, everybody. Computing truth functions is an essential skill in this class. We're going to do a lot of stuff with truth functions. So we need some more practice. Your job in this video is to compute this truth function and see if you can assess the sentence. So pause your videos now and practice this truth function. Okay, that was your chance. We're going to start talking about the answers. You should know the first thing to do is fill out your reference columns. So what I did is I wrote the sentence over here on the right, and I put my reference columns on the left. And you have to use, remember, canonical form. I also repeated the values of P and Q for you because that's helpful when you get started. If you didn't do that, that's okay. You could have just computed these values in red by looking at the reference columns too. So repeat these values under P and Q if you find that helpful. But why I computed these two red ones first is these are the narrow connectives. So these are the two connectives operating just on atomic sentences. That's where you have to start. I used those red values then in order to compute this conjunction. So the conjunction is true only on the bottom row because that's where both inputs are true. If there's an F in any of the inputs, like these Fs in red, then that's what's making the blue value in red. Now, once I've got the conjunction computed, I can now do this purple value where I just inverted, I negated the values in blue. So here, this thing in purple, this is the final answer. This is the truth function, TTTF. Now, in order to assess this sentence, what does this sentence mean? You should ask yourself, is this truth function familiar? Have you ever seen this thing? See if you can figure it out. Pause your videos if you need a minute, if you don't already know what this truth function is. See if you recognize this thing. Now, hopefully what you noticed is this is just disjunction. This is the truth function for or. So what we can say is this sentence that you just computed, this big sentence with all these negations and conjunction in it, this thing is logically equivalent to P or Q. And we say they're logically equivalent because they have the exact same truth function. Now remember, they are not the same sentence. To be the same sentence, they have to be the same string of symbols. And this is not the same string of symbols. This string of symbols has 3 symbols in it, P or Q. This one has like 8, 9, 10 symbols in it. So these are not the same sentence, but they're equivalent because one is true just in case the other one is true. The concept of logical equivalence is sentences that co-vary in truth value. If one is true, the other is true. If one is false, the other is false. So these are both true on row 1. They're both true on row 2. They're both false on row 4. They're always, if one is true, the other is true, and vice versa. If one is false, the other is false. That's what logical equivalence is. And we're going to have a symbol for this because we're going to talk about it a lot in the class. This double bar, double arrow thing is our symbol for logical equivalence. This is not a symbol we're adding to our language, by the way. This symbol is not in bool. We use this symbol to talk about bool. This is actually just English shorthand. This symbol means this thing is logically equivalent to that thing. That's all that that symbol means. Okay, thanks.